this is the end of the logarithms. What I'm going to do is, since we missed class last Wednesday because of the blizzard and closing the campus, we're going to skip 4-8. I think we can get by with the material without doing 4-8. If it's something I feel like I have time towards the end of the semester come back to, I will, but I'm not going to go over that. This is supposed to say, not 6-6, by the way, 4-6. Okay, we're in chapter 4. So let's go ahead and let's run through this. This is a pretty short section. It's just got two major ideas. And what we're looking at on this is log equations and exponential equations, okay? All right? And then your homework and stuff after spring break. I think I've got my math lab set up. So there's two sections due the Monday after spring break with logs, and then the rest of this is due like Wednesday. So I've got all the rest of the stuff for chapter 4 up then, okay? All right, so let's see. To begin with, when you're solving a log equation, you want to generally just sort of go through this strategy. You want to get all the logs on one side of the equation if you can, which is the way this one is. And then a lot of times you're going to use the properties of logs that we talked about, I think, in the last class, to try to write it in one log if possible. Then the typical thing, ultimately what you try to do is to write this in exponential form. And every situation is a little different. And once you write it in exponential form, then you can solve the equation. And then one thing that's real important on a lot of these log equations is to check your answer, particularly like if you get two answers. A lot of times one or both of them may not check. So you do have to check your answer and make sure it's right. So I'll be emphasizing that as I go through this. So this first one is a real standard simple example. This is a simple example as you'll see. This one you just immediately write in exponential form. Okay, so remember, if you write in exponential form, this is the base, this is the exponent, so you just say 2 to the third is equal to x plus 3, and then that's a super easy equation to solve. Okay, so this would be 2 to the third would be 8. You have x plus 3, and then you can subtract 3 from both sides, so you would end up getting x equals 5. Okay, that's a real simple logarithmic equation where you just write it in exponential form. Okay, the checking on this, and I think you gain a lot out of checking your answer on this because it helps you understand how logs work. So let's check the answer. So what I'm going to do is we're just going to plug the 5 back in. And this will kind of help us review the logs a little bit. So we're going to work out the log base 2 of 5 plus 3. Okay, well that is the log base 2 of 8. What's the log base 2 of 8? What do you raise 2 to get 8? That's the question. 3, exactly. Okay, so that is equal to 3 like it's supposed to be, so it checks out. Remember, that's just saying 2 to the third is 8. The answer to a log is an exponent. So that checks out. X equals 5 is the answer of the problem. Okay, so that's a real straightforward example on that problem. Okay, all right, next one. Now what you do on this one is you're not going to write it in exponential form or anything. Anytime that you have a log on both sides and you have the log of the whole entire side, you can just take the logs off. You're not really canceling the logs. You're not dividing by a log. You're just taking them off. You can take a log of both sides of an equation, and you can also just take the logs off. Okay, and you do that, you got a real simple equation that you can solve then. Okay, now you couldn't do that if there was like a plus 2 there or something. You couldn't take the logs off, so it's got to be the log of both sides. Now it's pretty straightforward, so I'm going to just do this. I'm going to move that x to this side, and I'm going to move the 2 to that side. So I'll get 3 plus 2 is equal to 5x minus x like that. Okay, so let's see. That ends up giving me 5 equals 4x, and then I just divide by 4. So I'd end up getting the answer x is equal to 5 over 4. Okay, that would be the answer of the problem, all right? Now, actually, when you check something like this, you can check this on a calculator too if you want to. So you're usually not going to have any trouble If you solve a linear equation, usually you don't have to worry too much about checking your answer. But if you did check your answer, what you would have is log of 5/4 plus 3. And we'll see if that's equal to the log of 5 times 5/4 minus 2. Okay? And really all that matters on this is if you work this out, you would end up essentially getting this. You could get a common denominator. Okay, like you got 5/4 and you got 3/1, so the common denominator is 4. So I'm just going to multiply that by 4/4. Okay, and if I do that, I'll have log of, this would be 12 plus 5 or 17/4, like that. That's just fraction arithmetic. And if I go over to this side, I would have, I could put the 5/1, multiply straight across would be 25/4, like that. Okay, then I can put the 2/1, and again get a common denominator. Okay, so now if you do this, notice you're going to get 25 minus 8 now. So you're also going to get the log of 17/4. So really all that you had to really do on this problem is just, verify that 5/4 works on that equation, x plus 3, 5x minus 2. Okay, and that's it. You can use a calculator to assist you with these kind of things too when you're checking. Okay, any problems so far? Those are the simplest ones. Now the rest of these, they get a little bit harder because we got to do properties of logs. So that's how the first two would work out. Now this one, what you're going to do is if you see two logs added, you have to remember, we learned this particular property. If you have log of x plus log of y, that's the same as log xy. Okay, so we talked about that, I think, in the last class when we were here, was when you do a log of a product, you can break that into the sum of the logs. So we're going to do this backwards. So what we do is we combine these two logs together to get log base 3 of x times x minus 24 is equal to 4. Okay, so you have to get into using the properties of logs now. Okay, so now what you would do is, since you put that together, you would write it in exponential form. Okay, so your exponential form, this is your base, and the 4 is your exponent. Okay, so you would write this as 3 to the 4th power, like that, is equal to x times x minus 24, like that. Okay, and you're going to end up with a quadratic equation, which you solve either by factoring or quadratic formula. Okay, all right, so let's see, 3 to the 4th is 81. If you work that out, multiply 3 out 4 times. Then you can do distributive property here to get x the second, and then minus 24x, like that. Okay, all right, what do I do next? It's a quadratic equation, so what's the next move? One side 0, okay, then try to factor. So exactly. So we're going to move this over to get 0 equals x the second minus 24x minus 81, like that. And I think this one factors. Sometimes they will, sometimes they won't. Okay. All right, any questions so far? Okay, so I'm using that log property. That's kind of the key, is the sum of the logs is the log of the quotient, or not the quotient, the product. Okay, this one will factor like this. You'll have x and x. 27 times 3 is 81. And then you've got to have a minus and a plus to get the signs to work out the way they're supposed to. Okay, so that's it. So that means the answers, and you don't have to write this step because you can do this in your head. You set each factor to 0, you would get x is 27, then you would get x equals -3. Okay. Now, one thing that's real important on this is you're going to find that one of these answers is going to work, the other one is not going to work. So that's why it's real important that you check your answer. Okay, so I'm going to start by checking the 27. Okay, that one's the one that's going to work. So if you plug it in, you would get log base 3 of 27 plus log base 3 of 27 minus 24, and we're going to see if that's equal to 4. Okay, and you're not going to do this on your calculator. You don't need to do this on your calculator. So this would just be log base 3 of 27 plus log base 3 of 3 like that. Okay? So you want to get to a point where you can do these logs fast in your head too. What is the answer to this log? What power of 3 is 27? 3, right. How about this one? What power of 3 is 3? 1. So that's 3 plus 1, so that's 4. So see, it works out. Okay? All right, so that one works out fine. And if you take the time to check, it'll help you understand logarithms better. So that one works out okay. So 27 is definitely okay. All right. Now what happens when you check the negative 3 is if you plug this in, you would have log base 3 of negative 3 plus log base 3 of negative 3 minus 24. Okay, do you know what's wrong with that? I already know it's wrong. Do you? There's something seriously wrong with this. Okay, do you know what's wrong about this? You can't do a log of a negative number. Okay, remember, you can only do a log of a positive number. So this is actually undefined. Okay, you can only do a log of a positive number. So log of a negative number is no. If you do log of 0, you can't do that either. Okay, so that's why it doesn't check, is because the log of a negative number is undefined. So that means that what you would do is that would come out, and then the only answer to the problem would be 27. Now that's very frequent that happens on these kind of problems, is something doesn't check. And don't assume it's the negative answer. It's possible that the negative answer could work depending on the equation, but usually what happens is one of the answers causes you to take a log of a negative number. Okay, it just depends on the situation, so go through the details and check and verify. Okay? All right, so everybody understand what I did there okay? Okay? All right, just be sure that you're on top of checking, because when you get to doing your homework on this, you have to throw out whatever solution doesn't work, and sometimes they both work, sometimes both of them don't work. It just depends. Okay, so let's see. Let's move to the next thing here, and with this one, we've got logs on both sides. Now you can't take the logs off because that 3 doesn't have a log on it. So it would be wrong to just take off the logs. What you have to do instead is you got to get all of the logs on one side. It's up to you which side you put it on. So I'm going to move that log to the left side of the equation. And by doing that, what I'll have is log base 2 x plus 1, and then that sign's going to change to minus log base 2 of x minus 2 is equal to 3. Okay? So a lot of times you got to get logs on one side. Now, let's see if we remember this. We talked about this last class. So we learned a property. If you have a log of x over y, that's the same as the log of x minus the log of y. So that's a common property of logarithms that you have to learn. So basically, anytime you see two logs subtracted, you put it together as a log of this divided by that. So we're going to use that property, and when we put this together, it'll go like this. So we say log base 2, x plus 1 over x minus 2 is equal to 3. Okay, so that's how that gets put together. Okay, the last problem we did the sum turned to a product. Now we turn it into a quotient if it's a difference. Okay, so now what you're ready to do is you're ready to do this in exponential form. So that's your base. 3 is the exponent. So you just say 2 to the third is equal to x plus 1 over x minus 2. Okay, that's the equation that ultimately that we need to solve to get this problem solved then. Okay, so 2 to the third is 8. Then I have x plus 1 over x minus 2. All right, this is an equation with fractions, so what do you need to do? What do you always do when you have an equation with fractions? What's the general thing you do? You get rid of the fraction, right? Yeah, exactly. So a good way to do this would just be to multiply both sides by x minus 2. Okay, and by doing that, that would cross that out, and then you have a basic equation that you can solve from here. So you could do a distributive property here to get 8x minus 16. So you'd want to go ahead and do that. Then you'd be left with x plus 1, like that. Okay, and then from here it's just kind of a matter of rearranging. I'm going to move the x. I'm going to move the 16, like that. So I would get 8x minus x equals 1 plus 16. So that's 7x is 17. Then I can divide both sides by 7. So I get x equals 17 over 7. Okay, like that. Okay? All right. And this one you're probably going to be okay with. Generally, on a logarithm, what you can do without going through all the details, what you can do is this. I mean, you can usually get by if you do this. So when you check, this one I'm not going to go through all the details on. I'm just going to, everywhere I see an x, plug in 17 over 7. And let's see. And I'll kind of show you what I like to look at on these problems is at a minimum is this. Okay, and generally if you do this, you'll be okay. All right, so is this a positive number? Yeah, so log of a positive is cool, okay? That's what you mainly want to look at. Is this thing a positive number? Yeah, okay, that's a positive number. So generally if you just look at that, you're going to be okay. All right, when you don't have to go through all the details. You could go through the details on that if you wanted to, but if you verify that that's a positive and that's a positive, you're going to be okay. All right. All right. Any questions about what I've done so far then? Okay. All right. Let's see. This next one's kind of gets a little weird. I think this one may end up being have a feeling this one might have a quadratic formula involved in it or something. Let's kind of find out. Okay. So how do you put together two logs that are added? Product, right? Okay, so it's a product. Remember, you've got the property that says log x plus log y is equal to log x times y. Okay, so you're going to put those two logs together by multiplication then. Okay, so this is ln of x times x plus 3 is equal to negative 3. Okay, so let's just start there. We did a problem like this, I think, a few minutes ago. Okay. All right, now this one, what you got to do is you got to write it in exponential form. So what's the base of ln? That's e, right? Okay. So what you would do is you would take that to that power, negative 3 is the exponent. So you would end up with the equation e to the negative 3 is equal to x times x plus 3 like that. Okay, now you got to solve that equation. This is going to be a quadratic equation. You'll have e to the negative 3 equals x to the second plus 3x. Okay, it's quadratic, so you got to get one side equal to 0. So you want to go ahead and just move the e to the negative 3 the other side. You can leave it as a negative exponent if you want to, but you would get 0 equals x to the second plus 3x minus e to the negative 3. Okay, so that's where I am in the problem. All right, does that look like anything that would factor? No way. Okay, so probably what's going to happen on this is you're going to have to do the quadratic formula. So you would have a is 1, that's the coefficient of x squared. You would have b is 3, and c would be negative e to the negative 3 because that is a number, by the way. That's a constant. Okay, we know that e is a constant. So what we're going to do is we're going to plug into the quadratic formula. I'm going to go ahead and just write it down. And we'll have b squared minus 4ac over 2a. So we're just going to crunch this out in the quadratic formula. We're probably not much we're going to do with it, though. So what we'd end up having is negative 3, b is 3, and then we would have plus minus square root of 3 squared. Okay, b would be 3, so we do 3 squared. And then we do 4 times a is 1, and then c is negative e to the negative 3, and I'd just leave it that way. Okay, that's fine. And divide by 2a, where a is 1. Okay, so you're going to have to use the quadratic formula and simplify this, and then we'll have to check on this too when we get an answer and make sure that we don't do a log of a negative number like we've been doing. So really all I see that you could do on this is just kind of work out a little bit. You would have negative 3 plus or minus 9. 3 squared is 9. You have two negatives, so that's going to be plus 4 e to the negative 3 all over 2. Okay, and that's what you would have as a potential two answers to that problem. Okay, now what I would do on this problem is I would do this, and I would do this just totally on my calculator. All that's really going to matter is when we check this answer is just seeing if either of these answers are negative. And I would just crunch this on the calculator. And really all that's going to matter is just doing that numerator. So I'm going to do negative 3 plus, and you can just watch what I'm doing. You don't have to do this unless you want to. I'm going to do negative 3 plus 9 plus 4e raised to the negative 3 and do that. Okay, and I'm just going to see if I get a positive answer or a negative. I'm going to get a positive answer on that. Okay, so that's a positive answer. So that means the plus one, that one's okay. All right, and then let's just try the other one. The other one is negative 3 minus square root. This may give you a negative number, and if it does, we'll have to throw it out. So that'll be plus 4, and then again, e to the negative 3. Oh, did I put the wrong thing in there. That should be e to the negative 3. And I need to take this out. So now I think I've got that in right. Don't worry about the divide by 2. That doesn't matter. Okay, so see, I got a negative answer. So the answers really were approximately 0.033. The other answer is approximately negative 6.03. Okay. Now let's look at why you have to throw the negative one out. And that's because if you go back to the original problem, you would have ln of negative 6, right? So you would have to throw that out. So this one comes out. So you want to, that's what we call an extraneous solution. So then the only answer would be this. Your final answer would be negative 3 plus square root of 9 plus 4e to the negative 3 all over 2. That's it. Now all that was the quadratic formula, but man, you got to be really careful about checking these problems. Okay, at least look for that you're not doing an ln of a negative. That's what it boils down to, so you can kind of take that shortcut if you want to. All right, does that problem make sense? Okay, all right, the thing on that is the e to the negative 3 is a constant, so that's going to be the c of the quadratic equation. Okay, that's what that is, okay? All right, so any questions on that? Okay, most of these are pretty straightforward. Just be sure that you're really careful about how you check stuff. The next thing I'm going to look at is exponential equations. This is just kind of a summary of what you do with logarithmic equations. So the only other thing we do in this section is exponential equations. Some of these things we've already learned how to do. So this is like one we would have done last week. The idea with this is that 8 can be written as 2 to the third. Okay, this is one type of exponential equation where you don't have to use logarithms to solve it. So this is really sort of a review. So what you would do on this problem, you would just leave the left side alone, and you would change the 8 to 2 to the third. Okay, and we talked about this last time. This is real important. If the bases are the same, and you don't have to write this down, but you can if you want to. If the bases are the same, then you would conclude that the exponents are the same too. Okay, it's the only thing that would really make any sense. So in other words, what I have is the bases are both 2, right? So that means these exponents that I'm highlighting in blue are also going to be equal. So you would end up with the equation 1 plus 2x equals 3. Okay, like that, all right? And that's because that 8 could be written as a power of 2. If that 8, if I had a different number that couldn't be written as a power of 2, there would be a totally different way to do this problem that would involve logarithms. So from here, I just subtract 1, I get 2x equals 2, divide by 2, I'd get x equals 1. Okay, like that, okay? These kind of problems you don't have to worry about checking on too much, but this one, if you checked it, you would have 2 to the 1 plus 2 times 1. So that would be 2 to the third, so that's equal to 8. Okay, so that's how that goes. All right? That's a real simple variety of an exponential equation. Any question on what I just did? Okay. Now, when we get to the next page, the rest of the exponential equations we're going to have to use logarithms on. We didn't do that in the previous section last week because all the problems I did were designed so that you can make the bases the same. And if you can do it this way. Okay? So this one is a little bit different. Like if you look at this number 7 here, there's no way to write 19 as 3 to a power, where it's just a simple whole number. So you have to take a different approach. So what you want to do on this, when you solve an exponential equation, you want to try to isolate the exponential expression. And what I mean by that would be, okay, if you had something like 2e to the x, that's not isolated until you get rid of that 2 that's in front of it. Or if you had something like 2 to the x minus 1, you want to get rid of that. You just want the number to a power to be isolated. Okay, that's what I mean by that. Then what you do is you take the log of both sides. It really doesn't matter which one you do, but generally, if you had a base 10, then you would use a log. If you had a base e, then you would use an ln. Okay, that would be the idea. But really on this problem that I'm doing down here, number 7, it's going to matter which log you do. Okay, then the rest of it, you just kind of use log properties. So this is already isolated. Okay, so let's just write down the problem. We have 3x to the x minus 1 equals 19. And it's your call as to which logarithm you do. I'm going to just do ln of both sides of this equation. Okay, if you do log, that's okay too. All right, it's up to you. So let's see if we remember some basic things. Do you guys remember what you can do to the exponent? If you do a log of something to a power, what you can do to that power? You can bring it down in front. There's a property that says that, and you may be, a lot of these properties may be new to a lot of you, but if you had something like log of x to the n, we talked about this last week, then you can bring that exponent down. That's a common log property. So this whole thing comes down. So what you would have is x minus 1 times ln of 3 is equal to ln of 19. Okay, so that's how that goes. All right, and the purpose of that is now your unknown is not in the exponent anymore, so you can finish it up. Okay, now the easiest way to me to finish this problem up would be to divide both sides by ln of 3. Okay, and then that way you would end up with x minus 1 is equal to ln of 19 over ln of 3 like that. Okay, and then you can just add 1 to both sides. You can just move that. So the exact answer you would get would be x is equal to 1 plus ln 19 over ln of 3. That is the precise exact answer to that problem. What in the world did I just do? Okay, so I think when you get to a point, in a few weeks when you're working on your homework and everything, I think my math lab's going to ask 2 things. They're going to say, what's the exact answer? Then they're going to ask, what's the approximate answer, by just doing that on your calculator. So I'm going to do this on the calculator. And if I do that, I get 1 plus, and then you'd have to go ln of 19, and then divide by ln of 3, and then we'll just round that off to maybe 2 decimals, I think is what the directions say. Okay, so that would be about, we'll say 3.68. So that's your approximate answer. Okay, that's it. So that's how you typically solve an exponential equation. All right. For checking on this one, it's just as easy to use the decimal to check. So all I'm going to do on checking is just take my calculator and I'm going to do 3 to the, and I'll just plug in the decimal answer, 3.68 minus 1, and then we'll just do it on the calculator. So if I do 3 raised to the 3.68 minus 1, that'll give us close to 19. It's not perfect because we rounded. So for all practical purposes, that's good enough, okay, because we rounded anyway, okay? All right, everybody understand what I did okay there? Okay. The reason we had to do logarithms again is because that 19 cannot be written as 3 to a power. So we're forced to use logarithms, okay? All right. Okay, so the next problem. This one we're going to do the same approach, same idea. Take the log of both sides. Now it's beneficial on this one to use the ln. It would work either way, but it's better to use the ln because you have a base e there. Okay, so I'm going to do ln of both sides. Okay, what do I do with the x plus 3? Where does that go? It goes down in front. That's kind of the key to doing these problems. So that comes down in front. So that would give you x plus 3 times ln of e equals ln of 6. Okay? Now this ln of e is going to start popping up a lot. It'll pop up a lot in calculus. You guys will work a lot with exponential and logarithmic functions in Calc 1. The idea with this is this is just log base e of e. It's equal to 1 because e to the 1 is equal to e, not 1. Okay? So anytime you see ln of e, that's equal to 1. Okay? You can figure that out. You could even do it on your calculator, and calculator will bail you out of that situation. So I just kind of ignored that because that's 1. So I get x plus 3 equals ln of 6. Then I can move the 3 to the other side to get x is negative 3 plus ln 6 as a final answer to the problem. Now, of course, you could also write this as ln of 6 minus 3 as well. I kind of prefer to write it this way. A lot of times if students write it this way, it's kind of unclear as to whether that minus 3 is part of the log, and it isn't. So the ln of 6 is its own part. So to me, it's a little better to write it that way. Okay? And that's the exact answer to the problem. So those two problems were done pretty much the same way with using logarithms. Okay? Everybody with me okay on what I did there? Okay? All right. So let's see. I'm going to do 2 more things on this to finish this up. This next problem is kind of one that I wanted to do because it's a little bit different. It's a different type of exponential equation. And this one, it looks like it's sort of like quadratic. It's not quadratic, but it kind of looks like it is. So what you want to try to do, anytime you have a quadratic equation, you usually try to factor. You want one side equals 0 and you try to factor. So I'm going to try to factor this thing then, all right? You couldn't really do logs of both sides on this problem because you'd run into serious problems doing that. It wouldn't serve any useful purpose. So let's see if we can factor this. Now that's the first term and that's the last term. I think this problem is designed so it factors. If it didn't, it'd be a little bit more advanced problem to do. But this one I think is going to factor. Okay? So let's look at the first term and think about what that would be. Okay, what would you multiply by itself that you think would give you 3 to the 2x? That's a good question. Students a lot of times are not used to factoring stuff like that. You know what that would be? You can find something. Any idea? 3x. Yeah, there you go. 3 to the x and 3 to the x, exactly. Okay, because when you multiply, you add exponents anyway, right? So x plus x is 2x. Okay, so you would basically just put a 3 to the x there, and you would put a 3 to the x there, right? Yeah.
When you put a 3 to the x and a 1 to the x, does the bases multiply?
No, you're still talking about this 3 to the x, 3 to the x. Now, there's really nothing else you could do on that because when you multiply, you just add exponents. I can't think of any other way to do that. Okay, see what you're kind of this is what you're used to seeing. You're used to seeing like x to the third times x to the third is x to the sixth, right? It's the same idea. If the bases are the same, which they are, you write the base down and add the exponent. So that's it. You're just not used to seeing that very much. Okay. All right, now we're going to try to do something with this 6. Now we could either do 6 and 1 or we could do 3 and 2. And this is where it gets maybe a little bit weird. Okay, so we're just going to try 3 and 2 and see what happens. Now the key thing is when we do the inner and outer from FOIL, we got to get 3 to the x. So see if this makes sense to you. So if I multiply this, now I see students do this all the time. This is not 9 to the x. What it is it's 3 times 3 to the x. There isn't anything else you can do. You can't multiply that 3 times 3 because you'd be going against order of operations. So that's 3 times 3 to the x. All right, there isn't anything else you can do with that. And this outside term is sort of the same idea. If you do 3 to the x times 2, that is not 6 to the x. I see students do that all the time. What it is it's 2 times 3 to the x. You can't do anything else with it, okay? Now, what are we shooting for? We're shooting for just a 3 to the x. It might help you if I put 1 times 3 to the x there. So can you make 3 times 3 to the x and 2 times 3 to the x add up to 1 times 3 to the x? Absolutely. You can have a plus there and you can have a minus there, right? Okay. So that's how this thing factors, is you'd have a plus there and you'd have a minus there. That's kind of weird, and that's kind of hard for students to see because you just don't maybe have any experience factoring anything like that. So that's how the factoring would go. Okay. The thing that you got to understand is that middle term is 3 times 3 to the x and the other one's 2 times 3 to the x. Not these things, okay? That's what you got to pay attention to. So now what you would do is you would do this. You would set each factor equal to 0 like we're used to doing. So I'm just going to kind of do this down here. I've got 3 to the x plus 3 equals 0. We're going to try to solve that equation. And then we have 3 to the x minus 2 equals 0, and we'll try to solve that equation. All right. Okay, so what I'm going to do on this one is I'm going to subtract 3 from both sides. I would get 3 to the x equals negative 3. Okay, now let me ask a question on this and see if you catch this. What happens when you take 3 to any power? Any power. Do you ever get a negative number?
Nope.
No, you never do. Okay, like if you do 3 to the 0, that's 1. If you do 3 to the negative 1, that's 1/3. So that has no solution. If you didn't see that, if you didn't see this, this is what you would do. You would probably do log of both sides, and then I would hope that you would see that you can't do a log of a negative number. Okay, so that factor right there doesn't have a solution. Okay, the other one does though. All right. So what I do on the other equation is I bring this over, so that would be 3 to the x equals 2. Now I'm going to do a log of both sides. You can either do base 10 log or ln. Most of the time I'm going to do ln. So I do ln of both sides. Okay, I would bring that down. That would be x ln 3 equals ln 2. And then the last step would be isolate x, so we're going to divide both sides by ln of 3 like that. Okay, and then this would actually give the answer to this problem. You would end up getting x is equal to ln of 2 over ln of 3. Okay, now that's it. Now if you were going to check your answer, I'd just change that to a decimal. And you'd probably do a little bit better if you did it that way. So I'm just going to do this on the calculator. But the exact answer is ln 2 over ln 3. Yeah.
Just to be sure, can you use the log as well?
Yeah, it'll give the same answer. So if I did like log 2 over log 3 on the calculator, I'd still get that same answer. So that's really up to you. What you're going to find in calculus, you're going to almost always use ln. That's going to be kind of standard. So I'll just round that off. Yes?
Why, when you have the 3 to the x equals 2, could you not just do the, like, where you switch it with the log and do log base 3, 2 equals x? And
You
then
could do
type
that
in?
too. You could do
That
that.
still counts.
Yeah,
as
it would still be
correct.
right. There's actually, you could end up kind of having an answer with any log in it. I mean, you could, once you get to this point, you could just write it in a logarithmic form if you wanted to. Okay? To me, since it's an exponential equation, it's just as well to do it this way. And when you get to doing your homework on this, how much flexibility my math lab's going to have, I don't know. So I'd probably just recommend that you just use an ln, almost always. The only time I wouldn't use an ln would be if I had like if I had like 10 to the x or something like that with a base 10. That's it. I would just get used to using an ln. Okay? All right, so that's how that goes. That's a pretty different kind of a problem that you'll see on your assignment when you get to it. Okay, so let me do this last one here. Then I think we'll take a break, and then we'll kind of start into the trig today. And this first trig section is very, very long, so we're just going to do part of it. All right, so this one is just kind of an exponential, an application of an exponential function. So this is modeling the population of a city. T is years after 1998. And then this says, when will the population of the city reach 293,000? Now this is built in that that this is in thousands. So what I'm going to do is let's start by just writing down the problem. And that 235 is the initial population. So what you're going to do on this, since this is in thousands, you're just going to plug in a 293 in for A, not a 293,000. Okay, because that's what the problem says, is they say that that number is in thousands, so we do that. So essentially what we're going to do on this problem is we're just going to solve this exponential function, okay? I don't think we've seen this yet, but remember, the first thing I said you always got to do is isolate the exponential. So this part right here that I'm circling in red, that has to be by itself. Okay, so the first thing that you have to do is you have to divide both sides by 235. Okay, and I wouldn't even do anything on my calculator till the very end of the problem. So I'm not gonna change that to a decimal. I'm just gonna leave it alone. Okay, and then the right side I'm gonna have e to the 0.044t like that, and then I'm going to do ln of both sides, okay? So just like the other exponential equations we've done, most of the time you'll see me use an ln, and the reason I want to use ln is because of that base e. Okay, again, I just use ln unless it's 10 to the x. That's kind of my thought process on that. Okay, so I'm going to bring this down. I'm not going to do anything with that until the very end of the problem. Okay, and like we've been doing, the exponent comes down in front, so you'd have 0.044t times ln of e. All right, what's ln of e? 1, okay? If you forget that, work it out. You can take your calculator, but you want to know that ln of e is 1 because e to the first is e. That'll pop up all the time. So that thing just becomes 1, so you can just kind of ignore that. So you end up getting ln of 293 over 235 is equal to 0.044t, and then you can solve this equation by dividing both sides by 0.044 like that, and then you would take your calculator. This is an application, so you would want to just do this on your calculator. And again, you know, if you get to a point where you're doing this on my math lab, it's always generally best to do your rounding at the end, okay, so that you won't cause you any headaches on the computer. So I'm going to do ln of 293 divided by 235, and just get that, and then divide that by 0.044. And this is time, so we're solving this for time. So to me, it makes sense to just round that off to 5, okay? And this says, when will the population reach that? Well, it would be, I guess this would be back in time. I'm using old textbooks that are like out of date, that are back in time. So what would that be, 2003? Okay, back years ago. So that's the idea. So I just wanted to do one problem where you work with an exponential equation that you have to solve using logarithms, and that's it, okay? All right, any question on what I just did? Okay, this section's pretty limited in what you do, so I put your My Math Lab stuff up, but you don't need to worry about it until you get back from spring break. Really on this, you can go ahead and get started on it during spring break if you want to, but these are the kind of problems that you're going to see, okay? Any problem with anything? Okay. All right, well, let's go ahead and take like about a 5-minute break. Let's come back at like 8:55, then we'll get started into the trig.